Yeah, thank you. Anais, welcome on our stage. It's DataOps Poland meetup. Once again, hello. Stage is yours, and
Awesome.
I'm stop sharing.
Awesome. Thank you for having me. I'm just going to go ahead and share my screen. Can you just confirm that you can see my screen? So I'm not
Yes.
going to go
Yes.
ahead and talk to myself about you seeing anything. Okay, awesome. Thank you so much for having me. This is really exciting. No, I'm not going to talk directly about data today. That's not my main field of what I'm working on, let's say. I'm going to talk about a deployment methodology called GitOps. And I'm just curious in the chat if you could just indicate with a 1 if you've heard about GitOps before, like just post a 1 in the chat. Let me just open the chat so I can see it as well. That would be interesting. So if you've heard about GitOps before, just posting a 1 in the chat would be really cool. If not, just post a 0. That's also cool, because I'm going to tell you a bit more about GitOps today, what it is and how you can get started with it, and how you can use GitOps best practices. Specifically, we have 2 tools called, one of them is Crossplane and the other one is ArgoCD. Awesome. So there are 2 people already who posted at once. So you've already heard about GitOps to various degrees, I assume. I'm curious if you've used GitOps practices in production before. Can you post a 2? Like if you're using any GitOps tools such as ArgoCD in production, that would be really interesting to see. Awesome. So yeah, otherwise, if you've, awesome. Somebody has used Argo before, that's great. Cool. So a bit more about myself. My name is Anais. I'm a site reliability engineer at Sivo. Sivo is a cloud computing company that's based on Kubernetes. So our main offerings are managed Kubernetes clusters. You can find the Sivo Twitter handle here on the right at Sivo Cloud to check it out. I also have at the end some more information on Sivo that might be interesting for some of you. And here on the left is my Twitter handle. I'm most active on Twitter. So if there are any questions after the presentation, or if there are any slides that you find particularly interesting that you might want to comment on, either post here in the chat or tweet at me on Twitter. I would be happy to see that. Awesome, somebody used Argo rollouts. I will talk a little bit about Argo rollouts or mention it as well. Yeah. Before I got started at Sivo, I've been there just like about half a year. I was working for several years in the as developer advocate, first in the blockchain space, and then since a year ago in the cloud native space. So just about a year ago, I got started with Kubernetes and Docker and everything related. So I'm still learning about all these cool tools. Some of them we use at Sivo, some of them we don't use at Sivo in production, but I hope I can share something new with you here today, or just provide my thoughts on those tools and those methodologies. Now, before I get started with the actual content, I always just like to set the scene of like, what kind of goals do I have in mind when I'm talking about these new cloud native tools that are built on Kubernetes that sound super fancy and allow you to use new deployment processes and methodologies. So one of the reasons why I like to show those tools is, first of all, to get excited. I want people to get excited about these tools, get excited about Kubernetes and the ecosystem it provides, the open source ecosystem and the tools, as well as all the projects that are building on top of Kubernetes right now and expanding the use of Kubernetes, let's say. So the first thing is always for me to get excited in those demos. I'm not saying that the tools that I'm showing here in those demos are best practices or what you would right now use in production. They are more like, this is how you could use them. This is how some companies that I've talk to use them, but it's not necessarily what we do at Sivo. So there's a difference between me talking as like what we do at Sivo within my day-to-day work, let's say, and what I like to show in those demos where I like to introduce people to new tools and new practices within the cloud native ecosystem. Now, the second thing is that we want to automate ourselves as much out of our job as possible. And I love this GIF over here of this man just like checking the tickets all individually. And I think that really represents some of the issues that we can run into, let's say, when we implement new tools and new platforms, when we get really excited about a new tool and then we're like, okay, let's go ahead and implement it. We often don't think about, okay, how do you actually configure it and how do you actually maintain it long term? And the problem specifically, and I will talk about that more throughout the presentation with Kubernetes, is that within Kubernetes, you have to do a lot of custom configurations to make things work, depending on the type of your workloads and the type of tools you're using. When you implement new tools and new platforms to use with your clusters, with Kubernetes, it can get pretty complex pretty quickly. So we want to prevent us ultimately having to be this middleman and checking everything manually, making sure everything is manually working, but instead start small and then expand from there and make sure that we along the way automate as much as possible, so we're not stuck at the end with a platform that's way too complex and just becomes completely unmanageable. So the next thing is that we want to think about, or when we use those tools, we want to think about different parts of our development lifecycle. When we go from creating new features to testing them, implementing our security configuration, our networking, anything that our workloads or application is dependent on until we deploy it, we have to think about what communication do we have in place, either between team members or within our team. And that's actually also something that specifically Crossplane and other GitOps related tools relate to. And how do you manage the communication within your team? How can you ensure that your engineers are empowered? How can you shift left where engineers can just test things and deploy things completely by themselves without requiring approval on every step along the way, whether they need infrastructure or other resources for their staging environments or any other dependencies for their applications. So one part is the communication. What communication have you set up within the team? Who is responsible right now to make approvals? What is the workflow like? And within that, we also have to manage expectations of what does our application have to do? What is the expectation on our deployment workflow? What happens if something does not work? What happens if things go wrong and so on, right? So we want to make clear, or we want to make sure that expectations are managed and they are clear within our development lifecycle. And that's also one part of it, of using GitOps. And I will talk about GitOps in a second more, is how can we empower the individual to know what the expectations are like and how to make sure they are met. And then we want to consider other dependencies that we already have in place, whether those are human dependencies or code and tool-based the dependencies. And then another part is obviously also knowledge transfer, specifically with Kubernetes. There's so many moving parts. And once you start expanding and using different cloud native tools, such as Crossplane or ArgoCD, you cannot have everybody within the team being able to use everything. And that's also one big part of GitOps, that engineers should not have to know what Kubernetes is necessarily and how to directly manage Kubernetes-based resources, but basically be able to deploy workloads, the applications by themselves. And that ultimately leads us to the following goals. Like, this is what we're aiming for, also with the tools that with Crossplane and ArgoCD that I'm gonna talk more about in a second. Just quickly pointing it out, if there are any questions, if anything is unclear, if you want to add anything, right? There's nothing wrong. Like, you can add anything. Like, if you have any comments, any thoughts, any questions, please put that in the chat. And I'm sure Philip or Thomas are gonna interrupt me and be like, hey, Anais, there's a question. So please do feel free to ask questions throughout the presentation, because I don't want to continue the entire presentation and then something has not been clear. But at the end, we will also have a more comprehensive Q&A. So if you can also reserve your questions for the end.
Yep, we are here. We are standing like a guard, so.
Awesome, great to hear. Okay, so ultimately, when I'm using new tools such as Crossplane and ArgoCD, I'm aiming for these for the following outcomes, let's say. First of all, I don't want to be stuck with a specific tool or a specific platform. If I start to use Kubernetes, I don't want to be stuck long-term with the platform that I chose right at the beginning of my project. So for instance, if your company chose one platform at the beginning, you want to make sure that you can easily transfer to other platforms once you see the need, and be able to invest the resources to transfer to other platforms and use other tools without locking yourself right at the beginning into one platform. So the first thing is high portability, and that's something that specifically Crossplane can help us achieve. And I'm going to talk about that more in a second when I talk more in detail about Crossplane. Now, we want to keep our teams very agile. We want to be able to respond to customer requests or like our own ideas and the features we want to add to our application as quickly as possible without having to consider all of the dependencies that we already have in place within our applications, within our infrastructure stack. And that is only possible if we have high observability into our deployments. And this is something specifically where GitOps can help us, in that we want to know always at any point in time, if something goes wrong, if everything is working, we want to always be able to know who deployed what, when, where, and how. And in case something goes wrong, that information will help us to easily debug what's going on and potentially revert any changes that we put in place. So we want to have high observability into our deployments. However, with all those, especially cloud-native observability tools, you have two major downsides. Either they come at very high costs, so you have to pay for a platform, or you have to spend a lot of time to implement and maintain the tools that provide you ultimately with the observability that you want or think you need for your application. So we also want to keep our operational management as low as possible. So if we implement tools such as ArgoCD or Crossplane, we don't want to end up in the situation like described earlier, where we just this person who has to make manual changes and check everything, even though we actually wanted to implement the tools to automate things. And then we also want to keep our security risks in mind, especially with Kubernetes. One of the main security risks are misconfigurations of our YAML resources. And obviously, the more tools you implement on your Kubernetes cluster, the more YAML manifests, the more custom configurations you have to maintain, and that obviously that scales in the long term. So we want to make sure that our security risks are kept low. And so my assumption is that ultimately you can work towards these goals really easily with containers and Kubernetes and the cloud native ecosystem, if you know how. And kind of the process of knowing how is what organizations and individuals try to figure out, which I'm trying to figure out still. Now I have to mention here, this is a quick disclaimer, that I'm really like I was thrown into the cloud native ecosystem and I've only used Kubernetes based tools so far. So this is what I know. There might be for your use case and for your deployment better solutions than Kubernetes. I acknowledge that completely. So I'm not saying that this is the universal solution for everything. It might not be the best one for you. Just putting that out there, that it might not be for your deployments the case that it's the best. And here's also what we want to prevent when we use Kubernetes. The first thing is that I pointed towards is over-engineering our application. It's really easy also when I deploy new tools on Sivo on our production clusters for our observability stack. When I deploy new tools, I quickly end up being like, oh, I can add this and I can put this on top. And why don't I enhance this with this other tool that goes alongside the tool that I actually want to implement, right? And then I end up making everything far more complex than it could originally be, right? And especially if I'm the one deploying that tool, I'm likely also the only one within our small team who has read the entire, or like more or less the entire documentation for that tool, right? So I also become a bottleneck in maintaining that tool. So we want to prevent that. We do not like doing that, right? That's something we want to be aware of. And then we want to solve actual business problems, because all of this, like the tools that I'm going to show you in a second, Crossplane and ArgoCD, they're amazing, like as like concepts, and they're amazing to see work and do what they are supposed to do. But ultimately, if they are not solving any problems that we have within our team, within our business, then why do we spend the time and ultimately the money on implementing them? So we don't want to waste time and money for implementing those fancy new tools, as fancy as they might be, if they don't solve anything, any actual problems. And then we want to prevent building unreliable services. And this is also connected to Kubernetes misconfigurations. If we end up implementing new tools that are completely misconfigured and that we soon have no idea what they're actually doing and how they do it, then we could easily end up in a state where we just deploy really unreliable services because they are ultimately dependent on a stack, on a technology stack that's not properly configured. So these are just the things that I'd like to keep in mind as like before diving into Kubernetes and GitOps and the Crossplane and ArgoCD in more detail. Now, how do we get there? How do we achieve that? I don't know how many people here use containers on a regular basis or who use Kubernetes on a regular basis. So I have this slide here. You might all know about containers. So excuse me if I'm repeating something that you already know about. For this presentation, you don't have to be an expert in Kubernetes. You don't have to be an expert in containers. I mainly want to focus on this wow moment of like, this is something that you can do with Kubernetes using tools built within the cloud native ecosystem on top of Kubernetes. But for a quick recap, so ultimately what we want to do is we want to move to a microservice architecture where our services, our different deployments are decoupled from each other. So we want to be able to make changes to service 2 without affecting anything else within our deployment workflow within our other services, right? Everything else should stay the same, and we should not affect our entire infrastructure just by us implementing a new feature in service 2 or changing the color of a button or something similar, right? It should all be kind of decoupled and be able to, you should be able to update those components independently from each other. Now, the problem here is that if you move towards this container microservice, cloud native deployment strategies, this kind of mindset of decouple your services and manage those containers independently, you can end up with lots and lots of microservices, such as these enterprises, these corporations, and then you will need a way to manage them properly. And you will not be able to depend on a central infrastructure team to help you deploy those services and make things happen within your deployment lifecycle. Cute ball of software. Thank you. Yeah, I thought the same when I first saw this graphic. It was like, I was blown away that this is even a thing. But yeah, you have lots of different dependencies between teams that don't even know that they exist, right? Like one team might be, or one part of the application of the infrastructure might depend on another part, and you don't know that those two components are actually there until something maybe that goes wrong, right? Yeah, so ultimately Kubernetes helps us manage our microservice-based applications, our deployment workflow, and that's also where ArgoCD and Crossplane comes in. Now, for those who are completely new to Kubernetes, if you have used Kubernetes before, I would also love to hear it in the chat. If you're using it currently in production, post that too. If you have used it in like test environment, post that 1 in the chat. If you've not used it, feel free to post a 0 in the chat. It would really help me so I know what to go on in more detail. Awesome. Somebody's used Kubernetes in production or is using Kubernetes currently in production. I would just independently of that, I would love to chat to you also maybe after this presentation, because I'm always curious on to what extent do people currently use Kubernetes and how do they use it and with what kind of tools. At Sivo, we heavily use Terraform to manage all of our infrastructure, but I can talk about that more later on. First of all, I want to give a quick recap on what is Kubernetes, what does it do? So Kubernetes, you basically have a Kubernetes cluster, and that cluster is made up of several nodes. Those are called the node pool. And usually when you interact with that Kubernetes cluster, you interact through the Kubernetes API with that cluster. So at the beginning, right when you get started with Kubernetes, you don't really care what type of nodes. You care about the size of the nodes, but you don't actually care of like where you schedule your workouts. You just go ahead and you tell the Kubernetes API, hey, please deploy this and this resource. Now, you would tell it usually you would tell through Kubernetes manifests, through YAML files, you would tell Kubernetes of like, hey, this is what I want to deploy. These are the configurations. Please go ahead and spin up those resources. Now, when you spin up a new application, a new container within your Kubernetes cluster, it would run the container inside a pod. Now, you can also run multiple containers within a pod. Usually you run in some cases several. And the thing is, the pod is like the smallest unit within your Kubernetes cluster. It runs your container. And pods, they live and die really quickly. So they are basically just there to manage the process of the container, like what's running inside. If that process is finished, good, the pod is done doing what's supposed to do. If it's an application that's just supposed to run and run, you would have other resources within Kubernetes in place to make sure that you have, for instance, in this case, several replications of your application. So you have, for instance, 4 pods running each the same workload. So if you have lots of traffic going to your Kubernetes cluster, it will be served from either of those pods and distributed across those pods. Now we can go into more detail on like how that's actually done, but ultimately what you have to remember is you tell Kubernetes, the Kubernetes cluster, please go ahead and spin up this application, spin up these resources for me. Now, this is usually done through a client called kubectl, and kubectl communicates directly with your Kubernetes cluster, with the Kubernetes API, and you basically need access to the Kubernetes cluster and tell it like, please go ahead and schedule those resources. Now, in this case, you will have one person or a few people or an infrastructure team who has access to this cluster. You wouldn't want to give every engineer access to the Kubernetes cluster. This is kind of where I want to get to, of like, how do you manage access to the Kubernetes cluster and make those deployments ultimately happen? And this is where ArgoCD can help us with. So let's just iterate, what's the problem here? Which I already touched on in the beginning. Which is basically when we're moving towards containers, we want to ultimately reduce the amount of resources and infrastructure that we have to manage, that we have to deal with. But the main problems, the main criticism of Kubernetes, like mentioned, is that we have to configure lots and lots of different resources, and it's not possible that everybody within your team actually knows how to do it, and knows how to deploy those workloads to Kubernetes, and knows how to use tools such as ArgoCD or Crossplane for your deployment strategy, maybe even. Now, there are other tools such as, they are fairly new, such as this one over here for serverless functions. So you can run serverless workloads on Kubernetes as well. So if you have especially static deployments, static sites, that you can use Knative to spin up the workloads with just a few lines of YAML files, of YAML configurations. And that would make it ultimately easier. That would reduce, those tools would reduce the amount of configurations that you have to do. But that's not always possible to use these tools. And sometimes you would even end up have to manage more resources using those tools than if you reduce the number of resources. And we will get there in more detail once I get to ArgoCD. So we want to ultimately manage our complexity. And this is just like to reiterate on, this is the cloud native ecosystem, the CNCF landscape. Now the CNCF, the Cloud Native Computing Foundation, is part of the Linux Foundation. It's like on the Linux Foundation. And it's hosting a bunch of different projects. Now, not all of these projects are actually open source. Not all of these projects are actually within the governance of the CNCF. Some of the projects are member projects. So for example, here we have Civo, the company that I'm working for. So we are a member project. Or like in this case, we are a Kubernetes distribution and mentioned here, but there are also some other member projects listed on the CNCF landscape. Now, especially the big boxes here we have Argo, and here we have Crossplane, are part of the CNCF governance scheme. So they start as sandbox projects when they are just getting started within the CNCF and they have very low adoption. And then at some point, once they gain more traction and more stability, they move into incubation stage. And once they're in incubation, they get more resources from the CNCF and more support from the community. And ultimately, the goal for these projects that are part of the CNCF governance scheme is that they are adopted in production by various enterprise companies or by various companies and can graduate from the CNCF. So here we have Kubernetes that's graduated. We have somewhere else Prometheus that's also graduated, which I can't find right now, which is probably not here on this little screenshot. But ultimately, there are lots of different projects within the CNCF ecosystem that build on top of the Kubernetes API and help us to expand the Kubernetes API into different use cases. For example, here that might be more interesting for people who are especially interested in DataOps and anything related to data management. Here are all the storage solutions that you can also deploy natively on Kubernetes as well, many of them. Now, this is usually the first reaction that people have when I show them this landscape. And this is the first reaction that I had seen this landscape. I was like, wow, this is a lot to manage. We just talked about, we don't want to introduce unnecessary complexity into our Kubernetes cluster. And we want to make deployments as easy as possible and empower our engineers to do deployments themselves, to spin infrastructure up themselves and make deployments happen. And now you tell me this is the landscape and this is like everything that's going on here. How can anybody possibly know what's going on and react to it and be able to reach those goals that are highlighted in the beginning? So usually when you use Kubernetes, you wouldn't necessarily start up with all of those tools. You would start up with a few, or you would start up with a few and then expand using additional tools later on once you have developed the know-how within the team and or you have additional need for those additional tools, right? It's like with many other different infrastructure stacks and deployment strategies, you wouldn't use all the tools right from the get-go. You would usually start with something simplistic and then expand and make it more complex over time. Now, this is also something else that I want to point out, and I just love to put these graphics, these memes in, because they really summarize of what the reaction of people usually is, of like, why would I even use Kubernetes in the first place if it's not actually solving a problem for me? And I'm not saying like with Crossplane or ArgoCD, you will solve your deployment and infrastructure management problems, but it could potentially help you in the long term to move to a cloud native, to the cloud native ecosystem and to more cloud native based deployments that are possible with those tools. Now, again, Kubernetes is not a solution for everybody. It might not be a solution for your company or your deployments, but it could be one option. And over the past years, and especially I think the past year, from what I've observed at least, the interest in Kubernetes by organizations has been growing, and it's really exciting to see more and more projects also building on top of Kubernetes, on top of the Kubernetes API. So this landscape over here is definitely expanding beyond what it currently is. So let's move on to the actual topic of this presentation. Now that we kind of have an overview of what do we want, what do we don't want, what is actually the cloud native ecosystem, what are we trying to do? So we want to develop new deployment models, whether that's for managing our workloads or application or spinning up and provisioning new infrastructure. Now, this leads us to GitOps. What is GitOps actually? What do we want to achieve with GitOps? It's not a complete new thing. It's not like, I wouldn't say it's as separate as DevSecOps and DevOps, where you really have people drawing a complete distinction. I would just say GitOps is a deployment methodology within the DevOps ecosystem, within DevOps itself. I wouldn't say that it's something completely separate. Now, within GitOps, the main thing that you have to keep in mind is that Git is our single point of truth. Anything that we want is in Git. Anything that we don't want is not in Git. Anything that our application depends on is in Git. And that's like either dependencies for our application, but also we could put all of the infrastructure that our application needs inside of Git as well. And that's possible through tools such as Terraform, as well as Crossplane, that I will show you later on, as well as part of the demo. Now, The thing is, if everything is in Git, we have several benefits because we know what is the history of our deployments, what are the changes that have occurred over time. That's different to if we just make changes directly through our UI. If we both use the same platform and I just go ahead and make changes through the UI, you might ask me later on, Anais, what kind of changes did you make? And I will be like, I'm not sure. I pressed a few buttons and something changed, and then it didn't quite do what I wanted it to do. So I pressed a few new buttons and now everything is broken, right? We don't want to be in that position where that happens. So if we agree that everything that we want is within Git, then I can see exactly what you're doing. And if you want to make any changes to what we have in place about our infrastructure or our application deployment, you can just follow the normal development workflow of like, you just create a PR and propose your changes, and then we can agree on those changes and approve them and run our CI/CD pipelines and get them inside of Git. Now, how does it connect with our Kubernetes cluster? The thing is that we don't want to give a platform or any tool that we're using access to any other tool that we highly depend on. So for instance, we don't want to give the applications that are connected to Git and Git access to our infrastructure, right? To our platforms. We don't necessarily want to give an external application access to our workloads. So what we can do within our Kubernetes cluster, we can deploy an agent. Now, in our case, the agent is going to be ArgoCD. There's another tool called Flux, also within the cloud native ecosystem, that you could use instead. It's a similar model. I'm just using, in this case, we're using ArgoCD because I prefer ArgoCD. So it's my personal preference. So anyway, we deploy this agent inside of our Kubernetes cluster. And this agent is ultimately responsible for making sure that everything that's defined in Git is deployed inside of our Kubernetes cluster. So anything that's within Git should be exactly the same in our Kubernetes cluster. What's in Git is our desired state, what we want to have ultimately. It's like the final dish that we want to cook. That's our desired state, what's within Git. Now, everything that's described within Git is basically the steps of how do we get there? What has to be deployed to get to this final state? And the agent is then responsible to deploy whatever in Git to our Kubernetes cluster. We don't make any changes directly. I don't go ahead and connect to the Kubernetes cluster and be like, here, please go ahead and deploy that, because then I could make human errors and be the only one who knows what I actually did, or maybe forget what I actually did. So by me just pushing things to Git and the agent pulling those things out, we prevent having to give an external application access to our cluster, and we make sure that there's an automated process for getting the changes from Git, from our repositories inside of our cluster. That's the main principle of GitOps. Everything should be within Git, and we shouldn't have to tell our cluster manually what it's supposed to do. The agent is supposed to take care of that. Now, the main thing here is, like, as I mentioned, is access control. And just to highlight that again, if I directly interact with the Kubernetes cluster, which I will also do within my demo, I would use kubectl, connect to the Kubernetes API to my Kubernetes cluster. I have my nodes running and everything. Now, in that case, I have access to the Kubernetes cluster. And the thing is, if I have to give people access to the Kubernetes cluster, they can do whatever. So I would have to configure additional role-based access control to make sure that people can't just delete resources or modify existing resources, right? But if they can't modify existing resources, then they probably need additional help for them making any changes or deployments happen. So I don't want to deal with all of that, right? I want to empower the engineers doing their thing, testing their stuff, but I don't want to give them access to my precious infrastructure. I do not want to do that, right? So the thing is with GitOps, you just provide the cluster with the knowledge on how to pull information inside of the cluster instead of Git pushing information inside of the cluster. So instead of pushing information inside of the cluster, you want to pull them in from the other applications. And similarly, if another application needs information from the cluster, you want to push those informations out as well. This is the main principle and the main benefit with that I see with GitOps. Now, if you've used GitOps in production, then you might have other benefits that you see as well. Currently at Siva, we do not use that kind of model. So what we do is a little bit different. But this is ultimately what GitOps is about. Now, a little bit more about ArgoCD. ArgoCD is part of the Argo project family. Now, Argo is right now, I think, still an incubating project in the CNCF. And it also has 3 other tools: Argo Workflows, Argo Rollouts, and Argo Events. Argo Workflows is basically pipeline. I wouldn't say it's like I wouldn't necessarily compare it with other CI/CD platforms, but you can basically run sequential and interconnected processes. So you can run, for example, sequential tests or similar workflows with Argo Workflows. Now, Argo Events can be used to set up triggers. So, for example, to trigger a workflow. And Argo Rollouts is there to implement more advanced deployment strategies. So, for example, you can use Argo Rollouts to make canary deployments happen on your Kubernetes cluster, to have like all kinds of different more advanced deployments of depending on how you want to spin up new workloads. So it's not just like through a big bang of like you delete the old resources and you spin up the new resources. So Argo Rollouts can help you with that. I have another really comprehensive presentation of Argo Rollouts on my YouTube channel, as well as on my GitHub repository, which I can show you at the end as well if you're curious to learn more about that. But we're going to focus on ArgoCD now. Now, ArgoCD helps us to basically do declarative GitOps to deploy our workloads to our Kubernetes cluster. So what does it mean to declaratively deploy our resources? That's kind of what I mentioned before. With GitOps, we already have to know what is the end state of our resource supposed to be. So we start from the end state, and then we work our way backwards of what has to happen to get there. Instead of the imperative approach would be that we kind of know what our application and our infrastructure and our deployment, everything is supposed to look like. And we figure out along the way on how to get there. That's kind of the button click approach of like, you want to spin up several different resources on your cloud platform, and you're just going to go ahead and you click different buttons until you have those resources that you need for your deployments. That's the imperative approach. With the declarative approach, we want to know what we need, and then just define how that's supposed to look like, how those resources are supposed to look like. And then by telling ArgoCD, hey, please deploy those resources now, we just work our way backwards to having everything spin up the way it's supposed to, the way we want it to be, let's say. Now, another benefit of ArgoCD is that it has a really comprehensive UI as well as a client. So you can also click buttons if you prefer to do that, or if you want to visualize what's actually going on within your cluster. The UI can help you really well to do exactly that. The other thing is that I like about ArgoCD that you can spin up any types of Kubernetes resources, whether you use Customize or Helm for your deployments. You can use Argo for that as well. You would just specify a different path to your resources, basically. That's the main difference. With Customize, you have with Argo additional configurations that you can put in place. But yeah, ultimately, you're not limited to just providing one type of YAML manifest, one type of way how you define your YAML files, your YAML resources. But yeah, so now that we know what ArgoCD is all about, now that we have ArgoCD and we know, okay, we can go ahead and we can basically deploy ArgoCD on our cluster, and then it's just going to pull from the Git repository, whatever we define within the Git repository, it's just going to pull it inside of the cluster. That's all great, but we want to have GitOps all the way. You don't just want to start with the deployment of our workloads, of our application. We want to also manage our Kubernetes cluster through GitOps. How is that possible? Well, if we want to do that, especially through ArgoCD, we have to define our infrastructure as Kubernetes-based resources as well. Everything has to be managed in a similar way, in a similar strategy, right? If everything is based on YAML manifests, it can become easier because everything is kind of following similar processes. That's at least something that I found, that once you understand how one thing works, it translates across different tools within the cloud native ecosystem, because everything is ultimately just another Kubernetes resource and more YAML manifests. So we want to also manage our Kubernetes cluster through YAML files. And that's what Crossplane helps us to do. So Crossplane is ultimately expanding the Kubernetes API. So what you do with Crossplane, and I'm going to start here and then I'm going to dive into the more details of Crossplane later on. What you do is you start with a Kubernetes cluster. It's a little bit of a chicken and an egg problem. I'm going to tell you that from the beginning. To use Crossplane, what you have to do first is you have to start with a Kubernetes cluster. It could be any Kubernetes cluster. It doesn't matter where this Kubernetes cluster lives. You just need a Kubernetes cluster where you can install Crossplane to. That's the first thing. You just install the Crossplane custom resource definitions. It's just basically a way of, if you don't know Kubernetes, if you don't know any of this, just think about this. You have a machine, you have some nodes running, and you install an application onto it. That's what it does, right? So in its most highest level, you just install the Crossplane resources, and then you have them running within your cluster. Awesome. So how do you use them? How do you tell Crossplane now, please go ahead and create this example cluster at the end, right? Next thing, you need a provider. Now, the provider is just basically a way. It's like kind of, if you know Kubernetes and you know what operators are, the provider is similar to an operator in Kubernetes. I can dive into more detail at the end if there are more questions on that and if there's interest of me expanding on it. So basically, you have to give this Kubernetes cluster, in addition to the Crossplane resources, the base resources, you have to give it a provider. Now, this provider can be an AWS provider, it can be an Azure provider, it can be any type of provider. There are lots of different providers in the open source Crossplane repository. Crossplane is all open source, so you can go ahead and check out all the different providers that Crossplane has in place right now and what you can do with them. Now, in our case, we're going to use the Siva provider. And once you have the provider, Crossplane will know how it can connect to the Siva API. How it can go ahead and basically request new resources from the Siva API. Now, the last problem that we have here before we can go ahead and tell the Siva API what to do is that the provider needs to have credentials. It needs to have a way of how do I connect at the end to an account that's running on Siva where the resources that I want to create live in. So in this case, I have here my account and I want to create this example cluster inside of the account. So to do that, for the provider to be able to access my account, I have to give it a secret. Like we need a secret basically that has my access token to Siva. So I'm going to have the base Crossplane resources that just specify how does Crossplane work. Next, I have here my Siva provider. And the Siva provider just tells it how to connect to the Siva API. Then I give it a secret and it now can connect to my specific account. Now, once I have that, I can give it a YAML resource that specifies how my Kubernetes cluster that I want to spin up is supposed to look like. So I can tell it this example cluster over here with these and these properties, this node count, this size, and so on. And these applications should be spun up inside my Siva account. So now I can go ahead and Crossplane can, through the Siva provider, connect to the Siva API and tell it, please spin up exactly this resource, how it's supposed to look like how it's defined within this YAML files, exactly how it's supposed to look like. And from this point onwards, Crossplane will be responsible for managing this cluster. Siva is only supposed to provision it. It's not supposed to managing it. It's not supposed to keep an eye and babysit my cluster. That's the job of Crossplane. And I will look at that and we'll tell you more about that in a second through the demo. But that's ultimately what this process looks like. Now, at this point, you can tell me, hey, Anais, you still have to connect through the Kubernetes API directly to this first cluster. Chicken and egg problem. You have an original cluster with Crossplane running on it, and you have to connect on it to install all of those resources, and then ultimately also to give the YAML manifest for the example cluster. But before that, you told me through GitOps, you actually don't have to do that. Well, in this case, what I'm doing for my demo, I'm doing exactly what I've described here. And then in the end, I will show you how you can use ArgoCD kind of separately within this provisioned cluster to spin up then your application within the cluster. Now, alternatively, you could do all of this hands-free by just simply, once you have installed these 3 resources, you're going to spin up ArgoCD within this cluster and connect it to a Git repository. Now, once it's connected over here, let's say to a Git repository, you can allow your engineers to provide this resource to the Git repository. So you don't have to give engineers or anybody else access to this original cluster that's running Crossplane. You just give it access to the Git repository that's externally. And then it will basically, once you give it you provide the resources, you push the resources to Git. The agent that's running within the cluster will just pull those resources in. And then Crossplane is in the same way able to tell the Civo API of like, hey, please create within that account this new cluster resource. And through that, you can have basically all of your engineers creating their own infrastructure, creating their own clusters, for example, their own Kubernetes clusters. That's basically the idea. So the first advantage is that you're shifting left, you're empowering your engineers to do their own thing, whether it's for testing purposes or for deployment purposes, right? So you're establishing this different kind of workflow, this more trust-based workflow in some cases, and you're allowing them to spin up new infrastructure. Now, the other great thing is with Crossplane, and I'm going to dive into that less so, that you can make complex platforms less complex. And that if you, for example, use certain types of resources within your organization, for your deployments, you can use Crossplane and then basically define, okay, we're using these types of infrastructure resources for all of our deployments. And these are the only types of resources that can be spin up on our cloud platform. And then basically anybody who needs to modify or spin up resources is basically constrained to only do it in a certain way. So you can basically define what people are able to do and what they are not able to do. If you use Crossplane, it can be this gatekeeper of like, I know about these kind of resources, and everything that I don't know about cannot be spun up. Now, if you want to learn about how that exactly works and the nitty-gritty details of that, I can refer you to an amazing YouTube account from somebody else who works for Crossplane, who is diving into the details of how that's actually done. What we have to know here is basically this process to start with of like, this is how we're going to spin up a Kubernetes cluster inside of Civo. And you could also potentially do that exact same process hands-free by installing ArgoCD directly on the original cluster and connecting it to a Git account. Now, in this case, it really focuses on the process of what you can, like how you can do it, and then you can do the exact same thing with other resources. So it doesn't have to be a Kubernetes cluster. It can be anything else that your cloud provider is able to do. For example, on the Civo, like on Civo on the platform, you can also spin up compute instances. So not just Kubernetes cluster, but also compute instances. So you could also use the Civo provider to do exactly that. You don't have to use it to spin up Kubernetes cluster. That's just what most people use it for. And similarly with other cloud platforms. So for example, with the AWS provider, you could spin up any AWS resource that's defined within the provider, which I think is everything. You can spin up on AWS right now, and you can go ahead and spin that up instead and define basically how are people actually able to spin it up. That's the main process. And the first time I heard about it, I was like, wow, this is amazing. This is sounds really cool, right? In theory, it sounds really cool to do it that way and to automate that process. But we still have to implement it. And this is where I started to struggle. And but what I'm going to show you now, like how can you actually go ahead and do it? It doesn't involve that many steps, as it might sound like when I'm showing you those little graphics. You might think of like, oh my God, there's so much I have to do now. There's actually not that much that you have to do to spin up those resources and to get the stuff working. That's actually, if you want to play around with it by yourself, it's actually, you can do it with the documentation in like, in a fairly quick time, let's say. Yeah, so you can, I basically want to show you how can you get started with that. Yeah, so let's go ahead and go into the demo. Now I have here's the Civo platform, and it's very straightforward. We want to keep it as simple as possible, so you don't have to read any documentation. You just go ahead and you go to your Kubernetes clusters, and I have already here this initial Kubernetes cluster running, and on that Kubernetes cluster, I have Crossplane installed. Now, how did I install Crossplane? I went to the documentation, and I went to install and configure. I like to show the entire process because a lot of times, especially when I get started with tools, I'm like, okay, this is all great, but you already know where all of the stuff lives, but I don't know where the stuff lives. So I don't know how to do it myself, right? So you can go here to the documentation and you click on self-hosted Crossplane. If you install it on your own Kubernetes cluster, they also have a hosted version, but we use the self-hosted version. And what you do is you create a namespace inside of your Kubernetes cluster where Crossplane is going to live in. So basically a separate section within your cluster for those who are new to Kubernetes. And then you install the Crossplane Helm chart. Now, what is a Helm chart? The Helm chart is basically, think about it as a package manager for Kubernetes. I know there's a lot to take in. Think about it that this command here with Helm is just installing a bunch of files, a bunch of YAML manifests. That's what it does. It's just a packaged version of everything that Crossplane needs for the very initial setup that we have seen over here for this part. That's all it does, all it needs. And that's basically what this Helm chart does. Now, I already went ahead and I did that step. I hope this is big enough. I hope you can see that. You should be able to see that. So I'm here on this initial cluster. I'm connected to it. So if I go to kubectl get notes, I have here my notes and get namespace. I have here my Crossplane system namespace that I created. And within that Crossplane system namespace, I have get all in namespace Crossplane system. And I have here the resources that basically this Helm chart spin up. These are the main resources that it's using right now, or that it created for me. Now, what I have to do now is provide it the CVO provider. So I'm going to go back here to the Crossplane repository, and oops, now I clicked it away. I broke my mouse yesterday, so I'm doing this about my mouse. Anyway, so you go here to the repository, to the Crossplane contrib, and you have here all of the providers. And I can just show you quickly all the different providers that you have in place. You have a Terraform provider, I think, for AWS, for Azure. You have an ArgoCD provider even that I haven't tried yet. You have here the Terraform provider. You have all kinds of providers that you can go ahead and use. So we want to use the CVO provider. It's over here. And the CVO provider will tell you how to install it. And I never remember that command. I don't think anybody should be able to remember or should remember that command. So I'm just going to go ahead and say basically through kubectl, I'm going to install this provider now. So just going to give that to the same Kubernetes cluster. And now it knows the provider, but it still doesn't have access to my CVO account yet. To have access to the CVO account, I have to give it this provider YAML file. So I can say provider YAML, and you can see here, this is how it looks like. It's pretty simple, at least in the case of CVO. Once you use the AWS provider and other providers, you have to specify a tiny bit more to get everything working. But here we basically have the secret, and the secret has my access code token, my encoded access token to my CVO account. And then I have here the provider config that's referencing the secret from before, Crossplane system. And it's just gonna basically give that to the CVO provider, and now then it can access my CVO account. So I'm gonna say kubectl apply, and then the file provider YAML, and it's just gonna deploy those two resources on my Kubernetes cluster. And once I have that, I can go ahead and I can deploy the cluster.yaml file, which specifies basically my my Kubernetes cluster that I want to spin up. Now, in this case, I'm going to say I want to name it Crossplane example. I want to have an instance of like 3 instances, 3 nodes running, and it should be small, and it should have the following applications installed. Now, I could do exactly the same through the UI, right? That's not the problem. I could go ahead and go through the CVO UI and do exactly the same thing, right? Just spin up a new cluster and just specify everything that I want to do through the cluster. But again, then you have the problem of I'm pressing a button here, right? And I mean, in the case of CVO, that's pretty straightforward. If I tell you, oh, deploy a medium Kubernetes cluster with Prometheus running on top of it, you will figure it out, I guess, in like 5 to 10 minutes of like, you just click your way through it and then you see, oh, here's some applications. So you find the application that I told you to deploy, right? But if it gets more complex, or you just don't want to bother with it, or you don't want to describe it, you just want to point people to a file or similar, that's when you could go ahead and just give people that configuration and be like, just use that to deploy your cluster. And then with Crossplane, you can also specify what types of application can people actually deploy. Maybe you don't want people to use any types of cloud native applications that are available on Sivo. Maybe they should only choose between a list of 5, right? That could also be the case. So let's just go ahead and deploy this resource before I start talking and explain too much while this actually has to spin up. Now in Sivo, it takes like about 2 minutes to spin up a new Kubernetes cluster. And it should get, it's creating now. So basically we have the workflow that I mentioned over here that I just gave this example cluster resource, this like Crossplane example resource cluster that I just showed you in the terminal to Crossplane. And it then was able through the Sivo provider with the secret access my Sivo account and tell the Sivo API, hey, please create this cluster that we want to spin up over here. So it's just spinning up the cluster that I specified over here. It's just going to do that. Now, again, I could also have running ArgoCD on this cluster and just specify a Git repository from which the cluster resource is supposed to be deployed. I could do that instead as well. So I don't have to interact directly with this cluster if I don't want to give people access directly to this cluster, right? Now, Crossplane is managing my cluster. So if I delete this cluster, which I can do at the end once I showed you the ArgoCD part, if I delete this cluster, Crossplane will be responsible to spin it up again. Like, because it's supposed to manage it. It's supposed to be the babysitter of this cluster, and it has to make sure that everything that's defined within my code, within Git, well, not right now, it's not in Git, but ultimately I would want to have this defined in Git, right? So everything that's defined here has to be true in that cluster. If I make any changes to my Kubernetes cluster through the UI, Crossplane has to revert it back. So now it's getting ready. It's probably still like some parts are still getting ready, but I could now connect to the kubeconfig through the UI. So in this case, I have to have access through the UI. Now, ideally, you would not want to have direct access through the UI either, right? Because that again means that if I have access to the UI, like in this case, I could also delete other resources in the UI, right? So what you want to do instead, you want to give people then a secret, and the secret has to have the kubeconfig that allows people to then connect to the cluster that you spin up. And I know this might sound like a lot to take in right now. Ultimately, this initial cluster has alongside this Sivo Kubernetes resource, it has a secret that allows you to connect to that Kubernetes cluster. That's basically what it does. So we're gonna hopefully paste in the command that I just tried to copy that I didn't copy. So let's go ahead and try again and paste it. Okay, so in this case, I just want to access the secret, which is cluster details for my Crossplane example. Ooh. And this is just going to basically save my kubeconfig into a kubeconfig file that then I can use to access my cluster. So now I have here my kubeconfig file, and I can export my kubeconfig and specify that I want to use this kubeconfig file over here. And now I'm connected to my Crossplane example cluster. Now, ideally, once you want to automate the process of people being able to provision their own Kubernetes clusters, you want to have an automated way of them accessing also, for example, the secret, so they don't have to use the UI itself. Now, if I go ahead and say kubectl get nodes, I have the nodes for this cluster. And if I say kubectl get namespaces, I have all my namespaces. Now I specified within the resource over here, where is it? Within here, I specified that I want to have ArgoCD installed on that cluster, and I want to have Prometheus, the Prometheus operator with the entire monitoring stack installed as well. So that's within those 2 namespaces. Now, at this point, I want to basically, whether or not you're using Crossplane, you want to now set up ArgoCD. And that's kind of the second part of all of this. Once you have all of this running, you have a cluster independent of if you're using Crossplane and to spin up the cluster or not. If you're using ArgoCD, you want to now set up ArgoCD to be connected to a Git repository. So we're going to go ahead and we're going to port forward to ArgoCD. So I think it's or we have to have the secret actually instead. So kubectl in namespace ArgoCD. So we have to get the secret from Argo, from those resources that are in this Argo namespace. And that is basically the password that allows us to connect to it. So let's say kubectl get all in namespace ArgoCD and check if the resources are actually already running. They are still pending, so we have to wait for them to be up and running. That's why it can't access the secret yet. So let's hope those are going to spin up so I can show you the second part of the demo. Let's just go ahead and kubectl describe. Let's describe one of those deployments. So I know what's going on. If they don't spin up in namespace ArgoCD, let's hope they spin up. It wouldn't be a demo if it wouldn't work, right? Okay. 2:1. Why is it not scaling up my resources? Is this the deployment? Okay, it's not. Let's see if the other namespace, if the monitoring namespace has deployed correctly. No. It's also not scheduling workloads over there right now. So something must have gone wrong in the process right now. Describing the pod. You think there's more information in the pod? Let me use Anais because I hate using kubectl. So
now we know it's live demo.
Yeah. Describe this poor pod.
By the way, nice tool. I also discovered it like a week or two ago. So
Not available. Pod didn't tie. I'm connected to the. Okay. To be honest, this is the first time I'm running into this issue. But the node doesn't seem to be ready right now. Oh, okay. Maybe if let me just delete some stuff. It's gonna delete it. Deployment. Yeah, this is a great tool if you know what you're supposed to do. Let's go ahead and delete this resource and then spin it up again. Delete cluster.yaml and then see if it's gonna. No. Oh, because I'm on the other Qt. Okay, export, and let's switch back to the other kubeconfig and let's delete the resource. So we can now see how Crossplane is gonna hopefully delete this cluster. Ideally. Yeah, no, it deleted the cluster. So let's try it again. Yeah. Anyway, you saw the Crossplane part, I hope. So if this doesn't work, then hopefully the other part was already like a wow feeling. Let's spin this up again. And hope it's gonna create everything correctly. We'll see. We'll see what's going on. I did exactly the same demo yesterday and it worked perfectly. I just want to say that.
Let's keep our fingers crossed. So everyone, let's do this.
Let's hope for the best. Funny. Let's see. At least, with Insivo, at least it doesn't take a long time to spin up new clusters. Like if this would be AWS, we would be sitting here for 20 minutes. And if it doesn't work, we wasted 20 minutes. So let's see what's gonna happen next. Maybe it's gonna work. Are there any questions in the meantime?
Actually, could you show us suggestions tab? I wonder what's there.
The suggestions. Oh, the suggestions. So we are highly community driven at Sivo. So you can actually, you can put suggestions in here on features that you want in the platform, for example, and then you can upvote what other people have suggested to Sivo. So we have this part, and then we also have a Slack channel. So most people actually use the Slack channel, the community channel, to provide suggestions. But this is like an extra part. It's very popular. You can also, within the content section, actually, we have a really large portal of different, well, this is because I'm logged in as admin. Let me not show you that. Let me show you something else. So if you go to Sivo directly, it's right now covered through the sivo.com. Oh, this is careers. That's what I want to show you at the end because we are hiring. But if you go to Sivo directly, you have within the community section, you have, especially if you're getting started with Kubernetes, this will be like a gold mine for you. We have a Sivo Academy where a bunch of different people, including myself, but also other people from the SRE team, have created courses. So you can get started with Kubernetes through these courses. And then we have a very, very big guides section over here, where like also community members are constantly providing you guides. And a lot of the guides are more technical. So here's, for example, the Sivo Crossplane provider, and here's in more detail of how does it actually work? What are the components? How can you get started, and so on. So check this out if you're curious about more of the detail, but the community section has a lot of different exciting material. Now let's see if the cluster has finished building. Let's see. Okay, it's supposed to have finished building. Now it's supposed to have installed my applications. Yeah, meanwhile, you can also check out the YouTube and the Facebook as well. So kubectl. And then what was it? It was like get secrets something. So it was get secrets cluster. Okay, we all have time, right? Oh, and I have to delete my kubeconfig over here, right? Remove kubeconfig. I've done it all before, right before, and it worked. So kubectl get secrets. Okay, and now I'm gonna connect to that cluster. And hopefully within this cluster, I can connect to it. And the namespaces, get all in namespace. Let's see if things are now here. All right, now they are spun up correctly. Okay, awesome. Now we have ArgoCD running. So now we can go ahead and we can get the secret from ArgoCD on how to connect to its UI and everything to tell it which Git repository to use. So in namespace ArgoCD, we want to have that secret. This is basically my password. So I'm going to use this password to log into Argo. So if I say ArgoCD log in, oh, I have to port forward first. So kubectl port forward ArgoCD. And now from this other terminal, I can, from this one, let's say, I can first of all connect to my kubeconfig. Oops, kubeconfig, and then I can log into ArgoCD, and I can provide it with my credentials. Hopefully, please work. Maybe I'm using the wrong version of ArgoCD, and it stopped working now. That would be one thing. Okay, now it wants to connect. Okay, so the password is the password that we just got out from over here. This is the password that we're going to use to connect to ArgoCD. Hopefully it connects. Wow. Live demos are fun. Next time I'm going to record it. I'm going to show you the recording. Oh,
yeah, that's one way to do it.
Again. Yeah, right. This is probably a better way. Why don't you want to connect?
But live demos are funnier.
Yeah, because nothing works, so people can help me debug it. No. Let's see. Okay, admin, and then password. Okay, now I'm logged in. Now I'm gonna also log in through the UI. So I'm gonna go to localhost 8080. And this is basically where I have now my ArgoCD UI, where we wanted to get to. Woo, that was difficult. No, it's usually not this difficult. Like, this was really a one-time thing. So, okay, everything up to here, when you're using ArgoCD, is usually done by the cluster admin, somebody who knows how to handle Kubernetes, not like me. Somebody who knows how to spin up the resources, how to use Kubernetes. They will spin up ArgoCD on top of their cluster for you, for everything. And then their last job is to, well, either to give you access to a domain where you can access ArgoCD directly, and you can tell it through the UI of like, hey, please create a new resource for my Git repository. So in this case, we have here the GitHub repository that I want to, oh yeah, good suggestion. So I could use this instead. No, so I could tell directly ArgoCD through the UI of what repository I want to deploy. I could also go ahead and do it through once I'm connected through my terminal, to Argo to the UI, like I'm here right now, like I'm logged in here right now. I can say ArgoCD and then app create, and this will create, and let's just create it in a default namespace. So this will create an app called React App. Like ArgoCD will know it as React App, and here's my Git repository. Through which they will basically know this is the Git repository that I want to use, and this is the path within the Git repository. It's basically within the manifest folder of my Git repository. So if I go to my Git repository, you can see here's the manifest folder. It has right now just two resources: a deployment resource over here, and then a service resource over here. That's all it has right now. Now I'm going to tell it to go ahead and deploy these two resources, and basically, you as an engineer, you will just then push changes to that Git repository, and ArgoCD within the cluster will be responsible to make the deployment happen. And hopefully it's going to now go ahead and deploy those resources. So application React App created. Awesome. So we can go back to the UI, and we should now see our application. Now, ArgoCD has an auto sync and a manual sync option. You can specify what you want to do. With the autosync, it will check your Git repository and compare the desired state inside your Git repository with the actual state running within your cluster. Like it basically every 10 minutes or something like that. Now we can go ahead and just manually sync both. So now what ArgoCD is going to do, it's going to spin up our two new resources, our two pods from our deployment that is specified within the Git repository inside of our cluster. So this is basically what the cluster admin or the person who has access to the Kubernetes cluster that runs ArgoCD is going to do. Now, you as an engineer, and I hope the Zoom bar is going to go up, I think you can do a lot more cool things with the UI that I just haven't tried out yet. Oh, look, you see the flow of dependencies. So here we have our deployment or our service. And in here we have our pods that the service is connected to. So you can do a lot of different things within the UI, and they're also continuously enhancing it. It's not just one thing just to say that they have the feature, they're actually enhancing it. So now what happens if we make any changes to our deployment, right? For example, I changed within that application, I changed the color of the buttons. Well, actually for that, I have to show you the color of my buttons. So right now, kubectl, get all, we can see within our cluster, we can see that those resources have been spun up. And I can do kubectl and port forward to this application to access it, to be able to access it in namespace. It's in the default namespace in this case. So I can just do that. And now I can go ahead and say localhost 3000, and I can access my application. So as you can see, they're blue buttons. Now I want to change the color of the buttons. I did that within the application, and I just want to deploy the change the different the different container image. So instead of 7, I want to say it's now container image 8. So I'm just going to go ahead and make the changes right here in Git. And I'm going to specify this has, oops, not 9, this has updated. And now I'm going to commit it. I'm going to just directly commit it to the main branch. And once I do that, and ArgoCD reaches one of those checkpoints, it will see like if the container image that's running within here, within our pod, within our deployment, is still the same container image. Now we'll then see, oh, the version that we have within Git is actually now 8 and not 7. It's different. So we'll make sure that those are the same. Now I can just go ahead and auto-sync those. And once I auto-sync, as you can see, ArgoCD will spin up a new pod. Now that pod has our new container image. These 2 pods have our new container image. At the same time, it will downscale our other pods. Now, this is like a big bang deployment, right? For something else, for more advanced deployments, you would want to use Argo rollouts to, for example, have 3 pods with the old and the new ones running at the same time or something like that. Anyway, so now it has our new deployment. So we can, again, go ahead and access our application. And once I refresh my application, I will now see that we have new color of our buttons. And this is all done by just interacting through Git directly instead of instead of making changes, instead of deploying those resources to our Kubernetes cluster. Because what you would do instead is, if you have your application locally. So in this case, I have here my application locally. I would just say deploy the manifest folder. I would say kubectl apply. But if I do kubectl apply, I need access to the cluster. And we want people to prevent having access directly to the cluster and just make changes in Git. And that's basically what GitOps is about. And what the whole process is about is that you can make changes quicker as well, because basically it's foolproof, more foolproof, let's say, with ArgoCD just managing it and doing the work for you. Yeah, and you know what's deployed and how it has been deployed, and people can interact on that. Now, this is the demo. Before I go to questions, because I want to make sure that people are still on here when I say this, because it's important for me to have said that, because I know that there are many smart people watching right now. Civo is hiring. We are hiring 2 Go engineers and 1 site reliability engineer. It's all remote, and we have a 4-day work week. So you basically work from Mondays to Thursdays. Yeah, so if you are interested, then please reach out and apply. It's at civo.com/careers, where you can find more information. Just want to say that. Awesome. And that's it. That's Civo. You can go ahead and try it out if you're curious. Also, try out the Civo Crossplane provider.